Hello everyone. So in this video we will solve problems using mesh analysis. So in this first problem, so we have asked to find the three mesh currents in the circuit shown below. So we have three loops here. So loop 1 with the 7 volt and 6 volt source and 1 ohm and 2 ohm resistors, and here this is taken as loop 2 with 1 ohm, 2 ohm and 3 ohm, and loop 3 with 2 ohm, 3 ohm and 1 ohm. So now we can solve this by using forming a mesh equation or by using a inspection method. So let us solve this problem by using inspection method. So we know that R into I is equal to V, and here we need to determine the size of the matrix. So it is n cross 1 n, and for I it is n cross 1, and for V it is n cross 1. So from the given figure, the number of loop is equivalent to the size, that is n for the matrix. So we have three loops here, therefore n is equal to 3. So the size of R matrix is 3 cross 3, and I matrix is 3 cross 1, and B matrix is 3 cross 1. So first we will determine what are the values for the R matrix. So here R is equal to R11, R12, R13, R21, R22, R23, R31, R32, R33. So these are the coefficients what we are going to find for the R matrix. So first we will solve the diagonal elements. So first we will take find a value for R11. So here this 1 denotes the resistance that is which are available in your loop 1. So take all the resistors which are available in loop 1 and you add and write. So here in this loop 1 we have 1 ohm resistor and 2 ohm resistor. So therefore R11 is equal to 1 plus 2, which is equivalent to 3 ohm. And next R22. So here this is from the loop 2. So here we have 1 ohm, 2 ohm, again we have 3 ohm. So 1 plus 2 plus 3 ohm. So total we have 6 ohms for R22. Next for R33. So from the third loop we have 3 ohm, 1 ohm and 2 ohm. So therefore 3 ohm plus 1 ohm plus 2 ohm, therefore 6 ohms. So these are the diagonal elements we have found it. And next we'll find R12, which will be equal to R21. So from first loop and second loop, the common resistor here it is 1 ohm. So we take this as 1. And we see the direction of the current here, it is given from here the current direction is from top to bottom, and here this I2 will reach this 1 amp 1 ohm resistor from bottom to top. So they both are in opposite side, so we give a negative sign here. And next we'll find R23, which is equivalent to R32. So here so this is my second loop and this is my third loop. So the common resistor here is 3 and the current are both in opposite direction. Y2 is flowing in clockwise direction from right to left, and I3 is flowing also in clockwise direction from left to right. So here it is minus 3. So this is the value for R23. So next we will find the value for R13, which will be equal to R31. So here from loop 1 and loop 3, the common resistor here it is 2 ohm, and the current sign is taken. So here it is minus 2 ohm. So these are the coefficients for R matrix. So now we'll write the R matrix coefficients. So R matrix will be equivalent to R11, the value is 3, minus 1, minus 2, and here R21 is equal to R12, and R22 we got 6, minus 3, minus 2, minus 3, and 6. So this is the value for R. And next for I, we have a 3 cross 1 matrix. So we are going to find 3 loop currents, which is I1, I2, I3. So this will form the I matrix. And next for V matrix. So here we have to find the voltage in the given circuit. So here from the given figure, so in loop 1 the sources are 7 and 6 volt. So here we can see the direction of current. So it is entering from minus and it is leaving from plus. So it is leaving in the positive side, and here the current circulates, and here it leaves in the negative side. So the total voltage in the loop 1, which will be equivalent to 7 minus 6. So that will be the value for the first loop voltage. And in loop 2 we don't have any voltage, so it is equivalent to 0. And in loop 3 we have one source, that is 6 volt. The current leaving direction here you can see it is in the positive side, so we take it as 6. Therefore V will be equivalent to 106. So this is the value for V. So this is the matrix equation we obtained for the given problem. So R into I is equivalent to V. So now by applying Cramer's rule, we can find the value for the matrix. So by using Cramer's rule, let us find the value for del 1, del 2, and del 3, so that we can find the value for the currents. So first step, we'll find the value for del, so which is equivalent to the determinant of the given matrix. So 3 minus 1 minus 2 minus 1 6 minus 3 minus 2 minus 3 minus 6. So we need to find the determinant for this value. So here the determinant will be 3 into 6 are 36 and sorry, it is plus 6. So 3 into 36 minus 9 and minus of minus 1 into minus 6 minus 6 and minus 2 into 3 and it will be plus 12. So on solving this we get 81 minus 12 minus 30, so which is equivalent to 39, the value for del. Next we solve for del 1. So replace the value of v with the column 1. So to find the determinant, first column will be 106 and the remaining will be the same. So minus 1 6 minus 3 minus 2 minus 3 and 6. So we'll find the determinant for this, which is equivalent to 1 into 36 minus 9 minus of minus 1 into 0 plus 18 minus 2 into 0 minus 36. So we'll get 27 and it is plus 18 plus 36 into 2 72. So the value for del 1 is 117. So this is for del 1. So now we'll find the first current I1. So we know I1 is equal to del 1 divided by del. So del 1 is found to be 117 and del 2 is, sorry, del is 39. Therefore the I1 current value is equal to 3 ampere. Next we will find del 2. So from the given matrix, replace the V values in the second column. So the matrix is 3 minus 1 2 sorry minus 2 minus 1 0 minus 3 minus 2 6 and 6. So we'll find the determinant for this value. So it will be 3 into 0 plus 18 and minus 1 into minus 6 minus 6 minus 2 into minus 6. So we'll get 54 plus 12 plus 12. So it is equivalent to 78. So now I2 is equivalent to del 2 divided by del. So it is 78 divided by 39. So it is equivalent to 2 ampere. So next we'll find the value for del 3. So here 3 minus 1 and 1 minus 1 6 0 minus 2 minus 3 6. So we'll find the determinant for this value, so which is equivalent to 3 into 36 minus 0 minus minus 1 into minus 6 plus 1 into 3 plus 12. So this is equivalent to 108 minus 6 plus 15. So it is equivalent to 117. Therefore I3 is equal to del 3 divided by del, which is equivalent to 117 divided by 39, and this is 3 ampere. So the value for I1 is 3 ampere, I2 is 2 ampere, and I3 is 3 ampere. Yes, the next problem. So here we are asked to find the mesh and branch current for the figure shown. So here it is a two loop system. So the first loop is P, Q, S and P. The second loop is Q, R, S and Q. So we'll solve this problem by using equation method. So we'll apply so now we'll apply KVL in loop 1. So here in this first loop, that is P, Q, S and P. So here the current enters to 30 ohm and then to 10 ohm resistor, and here the current direction both are given in clockwise direction. So here it is 30 into I1 plus 10 into I1 minus I2 is equal to 120 volt. So 30 I1 plus 10 I1 minus 10 I2 is equal to 120 ohm. So 40 I1 minus 10 I2 is equal to 120. So this will be our equation 1. So now in mesh 2 we will apply KVL. So apply KVL in mesh Q, R, S and Q. So here we'll get 50 into I2 plus 10 into I2 minus I1, which is equivalent to, and here we see the direction of current, it is leaving in the negative side, so it is minus 60. So on rearranging, minus 10 I1 plus 60 I2 is equal to minus 60. So this will be our equation number 2. So we need to solve these two equations and find the value for I1 and I2. So here let us take the equation 1 as it is, and let us multiply the equation 2 by 4, and then we'll add it. So here 1, it is 40i1 minus 10i2 is equal to 120. This equation 2 multiplied by 4, so it is minus 40i1 plus 240 I2 is equal to minus 240. So when we solve this, so we'll get 230 I2 is equal to minus 120. Therefore I2 is equal to 1 minus 120 divided by 230. So it is minus 0.521 ampere. So here now we got the value for I2. Now we will substitute that value in equation number 1. So from equation number 1, 40i1 minus 10 into value of I2 minus 0.521 equal to 120. So here I1, which is equivalent to 114.79 divided by 40. Therefore I1 will be equivalent to 2.86 ampere. So now we have solved this problem using the equation method. Now let us try the same problem using inspection method, and we will compare the answer for A1 and I2. So here by inspection method, R into I is equal to V. So for R matrix, so for R11, it is the first loop resistance, so 30 plus 10, so it is 40. And for R12, here it is the 10 ohm, which is common to loop 1 and loop 2, so it is 10. And here both the currents are in opposite direction, so here it is minus 10. So similarly R21 is also minus 10. And from loop 2, R22 value is 50 plus 10, so it is 60. And the two currents, let it be I1 into, and the voltage here it is. So here we see in the first loop, the direction of current is from minus to positive. So we have only one source, it is 120. And in second, we have a source of 60. The direction of current is from negative. So it is minus 60. This is the value for P matrix. So now we will solve for del, which is equivalent to determinant of 40 minus 10 minus 10 into 60. So it is 40 into 60 minus 10 into 10. So 2400 minus 100, this 2300. So next we'll find the value for del 1. So here replace the voltage in column 1, 120 minus 60 and minus 10, 60. So we'll find the determinant for this. So 120 into 60 minus of minus 10 into minus 60. So 120 is 60, it is 7200 minus minus plus 600. So this is equivalent to 6600. And next we'll find the value for del 2. So replace voltage in second column. So 40 minus 10, 120 minus 60. So determinant 40 into minus 60 minus minus 10 into 120. It is minus 2400 plus 1200 minus 1200. So now we have to find the value for the currents I1 and I2. So for solving I1 we divide del 1 by del, and for I2 del 2 by del. So I1 equal to del 1 by del, which is equivalent to 6600 divided by 2300. So it is 2.86 ampere. And I2 minus 1200 divided by 2300. So minus 0. And that is 0.521 minus 0.521 ampere. So in inspection method and by equation we get the same answers. Thank you.